Hey there, my name's Tim. I am an intern at Purdue University with the Trails program, and I just made a video of how to make a simple Opihi design uh, Onshape, a sort of cone roof with ridges. And right now I'm making a complex Opihi design that is a bit more accurate. You can see here. It's got that oval shape, the egg shape that is like the actual organism. So while it is a bit more complex, maybe it's the physics works better. Maybe this shape is what helps the limpet, the little creature, to not get damaged by all the waves. So yeah, it's part of the design, and I will show you how to make this with the hollowed out center and the ridges, similar to our simple, finished simple design here, which is just a circular cone, but this one is more of an elliptical egg-shaped cone. So come over here. This is what it looks like to start out a new document in Onshape. And again, make sure that you are familiar with the mouse controls. Holding down the right click is to rotate. Holding down the middle click is to pan. Scrolling the middle click is to zoom in and out. And let's click here to go to our classic view. What we're going to do to make our shape is very similar to the third way I showed in the simple Opihi video. It is the loft function. So what that does is it takes our bottom shape and it takes a point. Well, a loft function just takes two shapes or sketches and connects them with a 3D shape. So what we're gonna do is make a bottom shape and then bring it up to the top of a point, and then that will form our cone. And then we'll do that again to cut it out and make our hollow cone. So click on top, click sketch, click top view. These are all left clicks. And click center point arc. Make sure you're in the center. Click here, click on the radius, and then bring it all the way around to make a half circle. Now bring down elliptical arc, click the center, make sure it's straight up and down, this yellow dotted line. We want to click on the bottom first to create that radius dimension. Then we click on the side along our points to create that radius dimension. Then it's really easy to just bring it around to the other side. Click, and there is our finished shape. Now we get to dimension it. So the radius of this, we want this to be uh, one, yeah, 1 inch there. And then click on this radius. That gives us the whole height. We want that to be 3 inches, so a radius of 1.25, um, or a radius of 1.5, sorry. And so this is our radius of 1. This is our radius of 1.5. Of course, horizontally, this is still a radius of 1. And this looks good. That's our pretty similar shape to our Opihi here. You can see the egg-like shape. So click check, and that looks good. Now we're going to create the point that we will use our loft function and go from our base up to the point. In order to do that, we need a second plane that is offset from our first plane. So click top, click this plane here, and then it automatically makes it 1 inch up. And that looks good to me. We do want it to be 1 inch since our radius is 1 inch. So click check, and then click this plane, click sketch, click top view, and we're going to put a point here. Click right in the center. You can rotate see it is um, off, so it's not, because we're on our offset plane, that is our sketch plane. It is not on our circle, but if we go back to top view, it is right in the center, which is what we want. So click check, and here's where we do our loft function. Click loft, click this sketch, make sure it's the whole thing, click this point, and boom, there is our oval cone shape. Looks pretty good to me. We don't need to mess with any of these settings. Click check, and there is our first cone. So now we need to make a second cone to cut out of this to make it hollow, um, like this one. See how this one is hollow. So we come over here, we're going to do the same thing. Easily we can just hide this part so that we don't need to worry about it, but we can show these sketches so that it's helpful to see the general shape. That way where it's not super confusing. So click this, make sure it's the top plane, the flat one, the original one. Click sketch, top plane, go to top view, and we're gonna make a smaller um, arc on the inside here. So, or oval, egg, whatever you want to call it. Click center point arc, same thing. Go here, give our half circle, drop down to elliptical arc. These are all clicks. Make this up and down radius first so that we can just draw the straight curve. Click. Now we get to dimension this. We want it to be 1/4 of an inch thick all the way around. So if this radius is 1 inch, we want this to be 0.75 inches. And if this height of this oval is, our ellipse is 3 inches, then that means that we want this to be 2.5 inches in order to give 1/4 of an inch on each side. So our height should be 2.5, enter. And now that is 1/4 of an inch thick all the way around. Looks good to me, so click check. And then again, we need another plane for our point that we will make this cone with. And we don't want it to be right at the top, or else our cone would like get incredibly thin at the top. So we want it to be 1/4 of an inch thick even at the top. So we need a second plane. So we click plane 1, click new plane. We don't want it there. See, it's giving it an inch above. So we switch the direction and give 1/4 of an inch, 0.25 inches, because we want it down. That looks pretty good to me. Click check. And then we can either highlight it here or highlight it on the side. I'll just click it here. Click sketch, click top, and we're going to make another point. So again, it looks like it's overlapping everything, but because, so click point, click in the center. And because it is offset, we show that it is floating there. There's our first point, here's our second point, there's our original ovals, and we click check. So now, again, to keep things simple, it's easy that it just goes down in order of what we've made. And we can even rename these. Um, so I'll call this smaller point because it's the point for the smaller oval. And I'll press enter. So sometimes that can help you keep track of your different points or parts. So we're gonna do our second loft here. Make sure it's from the center oval to the shorter point, and that will create our smaller cone that we will cut out from the center. So in order to do this, let's show part 1, unhide it, click that eyeball, click loft, and it's really easy to just select these on the side. So our sketch 3, that looks right, it's our smaller oval, click that, and then our smaller point, that's the one that is on the inside, click that. And then it says Boolean resulted in no geometry change. So the reason it says that is because it's automatically adding our cone to our other cone, and it is um, not changing the geometry at all. So we need to click remove, and then it will remove it there. So that shows our smaller oval cone is removing from our bigger oval cone, and that's our hollow shape there. So remove faces, merge with all, just to keep it simple. You don't actually have to do that, but that's for if you have multiple parts. And that looks good to me. So click the check, and there is our shape. So now all we have to do is make these ridges, but it's a little bit more complicated than this one because it's not a perfect circle, so we can't just use this circular pattern. We can do it for half of our shape. We can do it on this edge because it is a perfect cone made of a perfect circle. So we can just rotate around there, but then we have to do some special things for this face, this edge here. So first, we need to make our ridge, and it's super easy because we already have this line here, this sketch along the edge. So we just need to make our circle for our sweep function that then we will bring across. So click right so that our circle is perpendicular. Click sketch, go to right view, click center point circle, click here. Actually, because of the other ridges, we're going to make our circle horizontal, and it will serve basically the same purpose. So, um, click here, click dimension, click, make it 0.05-inch diameter. And then this is perpendicular, but we actually want it vertical here, and we want it on the top, so we need that to be on plane 1. Let me just hide plane 2, not to make things confusing, because we're done with it, once we've made our shape. So we see we've got our top plane, and then we've got plane 1. I'll zoom out to make that super clear. We have our top plane, and then we have plane 1, and plane 1 is at the top. So, even though it's not the top plane, it makes sense. So right now our sketch is perpendicular, but we want it perpendicular with the top or flat. So we click sketch plane and then we click plane 1. We can either click it over here on the side or we can just click it here like that. Plane 1. So now our circle is flat. So we will use that for our side ridges, but we will also use that for our, that makes it easier for these ridges, and you will see why in a second. Um, that looks good. Our circle there, it's on the top, so we click check, and now we do our sweep. Click sweep, click this surface, click path, click this line. There's our ridge. Click new. We don't want to add a part. And there we go. And the nice thing about this is it is flat here on the bottom. And it might get a little bit funky and tricky up here at the top, but that's fine. We will deal with that. This is the best way to make the shape. See, with the simple Opihi, we made the circle perpendicular, so up and down, and that's why it makes this little dome here. But with the complex one, we need to make it flat so that I'll tell you why. So because we need to make new lines over this whole shape, and in order to use the same sketch, it'd have to be perpendicular to each line. So we'd have to have a circle like this direction, then this direction, then this direction, then this direction, then this, and that would just be very tedious. So if we just make it flat, then it can just keep going in each of the different directions and be the same thickness. But it's not quite as appealing at the top, which is fine. So now that we have this ridge, we can just make the circular pattern like we did last time. Go to circular pattern, click here, part 2, axis, choose this. Anything in the center will work. click that, or click that, or click that. Make sure it's flat. And we want 20 of these ridges. And since this is half, we will give 10. And you see here, it's going the whole way around. So it's going into the ground, which is, or into this shape, which is not what we want. We want it to only be on this half. So we pick 180 degrees there. And there we go. So it's 10 ridges along this edge of 180 degrees. Looks good to me. New part, check. Okay, now we need to make the ridges for this face and this face here. That will be pretty simple using our isocline function. So come here to this drop-down menu, choose isocline. It's this little circle-looking thing. And what that does is it makes curves or lines along a face. So what face do we want? We want this. Click here. What direction do we want? We want it in the right direction, I believe. It's either front or right. So click direction, click this right plane. No, I was wrong. We want it in the front direction. So click, we will use right at the very end, but we want it in the front. So click plane, click front, and you see it creates these two symmetrical lines. For some reason, this is 30 degrees along from this edge to the center, so 60 degrees total. I'm not sure why, but I found that out because it shows you how many you can do by changing the degrees. So let me show you. You can do 29 degrees, and it brings it almost to the center. But if I put 30 degrees, um, oh, never mind. This is a different shape than my previous one. I must have changed some of the dimensions. So that's nice. We can figure out how far this is so we can figure out the spacing. So it lets me do 30 degrees. Let's try 35. It does not. Let's try 31. It does. 33. It does. 34. Okay. So this is 34 degrees from this edge to this center. And that means it is uh 68 degrees, kind of a random number, the whole way around. So 34 divided by 5 or 68 divided by 10 is 6.8 degrees. 68 divided by 10 is 6.8. So if we want 10 ridges along these, which is 68 degrees, that means they'll have to be 6.8 degrees separated by each other. We'll just round that up and say that it's 7 and see how it goes. Basically, if none of that made sense, don't worry about it. That's only to decide what this degree angle is so that we can decide where these lines are. I'll show you, because if I put 3 degrees, the line is there. 6 degrees, it comes out a little bit. Try 12 degrees, comes out even more. So I said we need these about 7 degrees separated. So I'll start with 7. 7 times 1 degree, and it brings it there. There's my lines, symmetrical lines. Click check. I will do that again until it brings me out to the center, just doing multiples of 7. So, really quick, click isocline, click this face, click front, click direction, click front, and then give it 14 degrees. 7 times 2. Do it again, isocline, face, front. 7 times 3 is 21. Check. Click isocline, this. This is our second to last one. Click direction, click this front, somewhere along that plane. And then 7 times 4 is 28. Enter. Now, because of our shape, it gets a little bit more stretched out. So it's not totally even with the degrees. So I'm just going to give it 29 or 30 and see how that looks. Yeah, 29 looks pretty evenly spaced out. So because it stretches here. So we change these degrees, click check, So that was 7 degrees, 14 degrees, 21 degrees, 29 degrees. And now we'll use this center, which instead of using the front plane like I showed earlier, you use the right plane. So last one, click isocline, click this face, click somewhere on, click direction, and then click somewhere on the right plane, or you can just highlight it over here, click right, and then it automatically does 3 degrees, but we want 0 so that it's right in the center there. So now these are all of our lines that we will sweep our shape across. So click check, and then, oh, sorry, thought I had to sneeze. Okay, so now we will perform our sweep function. There's too much going on up here for us to click on our circle, so we're just going to make sure that we can find it over here. It is our sketch 4, remember that, so unhide. Let's just rename it to make it easier. We'll call that top circle. Click enter, so that is our top circle. And then we're just going to go through and sweep it along all of these to make our ridge. So we click sweep. What faces do we want? We want top circle there. What path do we want? Click on path and click here. Now, ideally, we would be able to just click on all of these paths and it would just make it all at once. When I tried it last time, it did not work, so let me try it again. So since it's already highlighted here, I just start clicking on these other ones. And there's something about the geometry, I think because it intersects at the top, that it does not like that. It does not let me do that, which is why it's showing up red. So I'll just do one at a time. It'll be quick enough. But see here, here's my ridge. For some reason, it makes it flat on this edge and sharp on this edge. I'm not sure why. That has to do with the geometry of the isocline, but that's fine. We'll just go through and get rid of these sharp edges once we finish. So this looks good. We want a new solid from the circle to our curve 1, and that is our ridge. Looks good. So just very quickly go through and do that for each one. Sweep, top circle, path is this. Click check. Sweep, top circle, path is this next one. Click check. We have 2 more. Sweep, top circle, path, these lines. Click check. And the last one, click sweep. We need to scroll up, click top circle, click path, click the center line, and click check. We are done. So there is our ridges. The only things we need to take care of are cutting down these sharp little edges here to make things simpler and easier, especially for 3D printing, and then just getting rid of this little spike because we don't need that. That was a byproduct of us doing these sweeps. So first, we'll extrude, remove extrude to get rid of these. So click front, click sketch, click front plane, and corner rectangle, click here, click check, and then we're going to use the extrude function. Click, click, extrude, click remove, click through all, click symmetric, click merge with all. And that just gets rid of all that and makes it flat, which is nice. Click check. And now our bottom is flat. It's a little bit different on either side, but it's the general shape, so it doesn't really change anything. Now we just need to get rid of this little point here. So it's on the side. So we go to our left view, click sketch, click our plane. We will make a rectangle, corner rectangle, or no, center, aligned rectangle. That's what we want. So we click somewhere along here, about cutting through there, here. Doesn't have to be perfect as long as it basically gets rid of the shape, and then click here and click check, because that is our general shape. Now we click our extrude. And here's the important part. This might intersect with some of these, but we don't need to cut through these. We only need to cut through these up here. So we click extrude, click remove, click through all for the shape, and click symmetric. That's only for the shape. That's not deciding what it actually cuts through. Here's the important part. Merge scope, and then we can click these ridges here. So click, 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 click. And if we zoom in, it shows that it is cutting it straight there, but it's not cutting any of these ridges. It might just make a slight sliver. So again, that was an extrude. We removed through all symmetric, and then our merge scope, we just clicked on all of our um, different colored ridges on the right. Click our check, and boom. Looks pretty good to me. We don't have any weird stuff going on here besides all that goodness there. Um, we've got our ridges, we've got our oval-like egg shape, and it is hollow. So there is your complex Opihi design. Um, again, let's look at the simple Opihi design. Go to the classic view, and this is what the Opihi looks like. And quickly, I will just show you how to export this to an STL file. Since it's not quite as easy as the simple one, I can show you. What we did with the simple one was we joined all these parts together and made a Boolean, and then we just exported that. Let me try that. I don't think it's going to work because of complex geometry. Usually Boolean, if it's too complex, if there's too many things going on, it doesn't like merging everything together. So click Boolean, says union, and see there's these red things that shows up. It doesn't, something's weird. So we'll just not worry about that. Click X. It's super easy. Come over here. We have a bunch of parts and some curves. We don't need to worry about the curves. Click on part one, scroll down, shift, click on your like your highest number part, your lowest part down here. So that for me is 16. I clicked on part 16 while holding shift. It highlights everything. Right click, export, and then I can export to STL. I want millimeters because that's what most 3D slicer softwares use, 3D printer slicers. This is where you use to get to a 3D printer. So I will name this, I'll just call it complex Opihi because it's my STL file. I can make any file of here, but I want STL so I can 3D print. Fine resolution just so that it's high definition, download, export, and I am done with that there. So here's our Opihi. Um, here is our design. So hope you liked designing these. Um, feel free to be creative and change the dimensions, change the size. If you figure out an easier way to make these ridges, go for it and let us know how you did. And yeah, make some cool stuff. Thank you for watching.